We've already talked about how to find the correlation between two variables. We've talked about how to find the least squares regression line, the linear regression. But we need to talk about some of the features and limitations of that. The first one is, if you want to make predictions for values of the explanatory variable, and what if they're outside the range of the data? Well, that is called extrapolation. In general, it is best practice not to use the regression line to make predictions for X values that are outside the range of the data, because that relationship may not hold there. Take this for example. So here is what's happening that we know of. But what if in the future it levels off? If we make a prediction too far into the future, outside of the data given, we could make some errors. So we try not to make predictions for values that are outside our data range. Now, the next thing I want to talk about are what are called residuals. So let's take a look again at our scatter plot and our regression line. The residual, our residual is the difference between the observed, what we actually saw, as in this example, the price of the house, minus what we predicted from the regression line. So if we're using the line to predict the selling price from a house, here's our line. We may compute the residual for the point 2,555, 426. What I mean by that is we know that a house that was 2,555 square feet sold for 426,000. Well, if I plug in that X value into my equation, I get 413.6. That's the predicted value, that Y hat. That's our prediction. But we know it actually sold for 426. So the residual is a difference between what was observed, the 426, and what we found. So those are pretty easy to find. It's just the vertical distance between the actual point and where it would be on that line. And remember, that's why it got its name. It's the least squares of all those differences. And so that's why we call it the least squares of all those residuals. Okay, now I could take all of those residuals and plot them. So a residual plot is a plot in which all the residuals are plotted against the values of the explanatory value variable X. When two variables have a linear relationship, the residual plot will not exhibit any pattern. Now, if the residual plot does exhibit a pattern, such as a curved pattern, then the variables do not have a linear relationship, and we really shouldn't be using that regression line. Even if our correlation coefficient was close to 1 or -1, the relationship still may not be linear. So to determine whether two variables have a linear relationship, we really need to look at the scatter plot to see if it forms a line. Or we can look at the residual plot. So that's another way we can look at it. So let's take this for example. This was our square feet and our selling price. These would be the predicted values. So the values from our line. And this is the residuals. When we plot those, notice that we get them everywhere. There's no pattern. That proves that there was a linear relationship. Now I can actually do that on the calculator as well. Let me get my calculator. Okay, so I have my X values and my Y values of the observed. To Let me get in here real quick. Okay, so to get the residual plot, I'm going to go into the stat plot. Still want a scatter plot. Now, if we were just looking at the normal scatter plot, we have L1 and L2. What we're going to do is for the Y values, I want the residual. Now, there is a feature called list right above stat. And so we're going to press second stat. And look, there's all our L1, L2, L3, but look at number 7. That stands for residual. So I'm going to select that and I'm going to do zoom stat one more time. And no pattern, the least squares regression line is appropriate. Now, the next thing I want to talk about is an influential, uh-oh, this marker's dying. Let's switch. An influential point. Not an influential person, but an influential point. Is a point that when included in the scatter plot strongly affects the position of the least squares regression line. Think of it as kind of an outlier. It pulls the regression line when we include a point. So consider a scatter plot of farmland versus total land area for US states. The blue line on the plot is a least squares regression line computed for the 48 states if we don't include Texas or Alaska. If we include Texas, it pulls the line up here. Because Texas is kind of an outlier as far as land area and farmland. Now, if I include Alaska, they have less farmland, but more land. So if I include Alaska, it pulls the regression line there. So the red dotted line is when we include Texas, and it moves the line somewhat. The green dashed line is if we include Alaska, so it caused a big shift. So influential points are troublesome because we want to summarize all the data rather than reflect the position of a single point. So when we contain outliers, the least squares regression line should be computed both with and without each outlier to determine which outliers are influential. Notice you would have seen immediately when you include Alaska how much that line changed. It's not even matching the overall pattern. Texas, a little bit, but not as much as Alaska. So that's why we have to be really careful with outliers. Now, the next thing we're going to talk about is something called the coefficient of determination. Now, we noticed that we can have a difference in our predicted value from our observed. And those are our residuals. Now, the difference between our mean of those Y values and the predicted value is the explained difference. Like it's the line explaining the difference. And that's kind of hard to fathom in this graph. But we want to talk about how much does this line explain the differences we find in our values versus what we can predict. And that's called the coefficient of determination. When two variables have a linear relationship, the correlation coefficient tells how strong the relationship is. So R tells how strong it is. But we can also look at R squared. R squared is the coefficient of determination. It measures the proportion of the total variation that is explained by the line. So we had calculated R to be 0.9005918. R squared would be just squaring that. But also our calculator gave that to us, by the way. So when I went in here and did my linear regression, it gave me R, but it also gave me R squared. R squared is 0.811. What this means, this is the coefficient of determination. Also sometimes called the coefficient of variation. The coefficient of variation. Because it's telling us how much of the variation is explained by the regression line. So this value 0.811 means that 81.1% of the variation in the selling price is explained by the regression line. And that's really good to know. So R squared is giving you the percent of the variation in selling price that is explained by the regression line.